Lesson 5.3, Sum and Difference Identities. These identities aren't going to be as common as the Pythagorean, reciprocal, and quotient identities, but they're still going to be useful. You should have these identities on your sheet. The one you may want to add is the sum and difference for the tangent that I wrote on the bottom. That one may not be on your sheet, and we probably will go through and use that form of the identity more often. You don't have to write this down, but there's a few hints on here on how you can help or try to remember which signs correspond to which when talking about the cosine and sine and tangent, those sum and difference identities. In the first example, we want to find the cosine of 15 degrees. So we're going to use an identity, one of them for cosine, the sum or difference, and we want to use the unit circle. So we want to think of common angles on the unit circle that we could use to come up with 15 degrees. If we're thinking about quadrant 1, we have 45 and 30. If I take 45 degrees and subtract 30, I come up with 15 degrees. So we can use this difference identity for cosine. So we break this up into the cosine of 45 degrees minus 30 degrees, and using the identity, we break that apart further into the cosine of 45 degrees times the cosine of 30 degrees plus the sine of 45 degrees times the sine of 30 degrees. Now we have to use our unit circle to rewrite each of these values. The cosine of 45 degrees is radical 2 over 2. The cosine of 30 degrees is radical 3 over 2. Then we have plus the sine of 45 degrees is radical 2 over 2. And the sine of 30 degrees is 1/2. So if we want to combine these terms, radical 2 times radical 3 is radical 6. 2 times 2 would give us 4 in the denominator, plus radical 2 times 1 is radical 2, over 2 times 2 is 4. The last step, we can combine this into one fraction. We would get radical 6 plus radical 2 all over 4. In this next example, we want to prove the cosine of pi over 2 minus x is equal to sine x. So we're going to start with the left side of the equation, the cosine of pi over 2 minus x, use the difference identity for cosine, and simplify it to get sine of x. So using the difference identity to expand this out, we have the cosine of pi over 2 times the cosine of x plus the sine of pi over 2 times sine of x. Using the unit circle, the cosine of pi over 2 is 0, so 0 times cosine x will just be 0, plus the sine of pi over 2 is 1 times sine x. If we simplify this down, we just get sine of x. So we prove that the cosine of pi over 2 minus x is equal to sine x. In this next example, we want to write the expression as the sine of an angle. So we have the sine of 22 degrees times the cosine of 13 degrees plus the cosine of 22 degrees times the sine of 13 degrees. If you look at your identity sheet, if we have sine times cosine, and then an addition plus the cosine times sine, this is going to be the sum identity for the sine function. So looking at your sum identity for the sine function, we can rewrite this as the sine of 22 degrees plus 13 degrees, which we could just simplify to get the sine of 22 plus 13 is 35 degrees. In this last example, we want to prove that the tangent of theta minus 3 pi over 2 is equal to negative cotangent theta. So in this, I'm going to use the identity that I wrote down towards the beginning of the lesson that I told you to write down on your identity sheet, rewriting this in terms of sine and cosine. So if we start with the tangent of theta minus 3 pi over 2, we can rewrite that as the sine of theta minus 3 pi over 2 divided by the cosine of theta minus 3 pi over 2. Now we're going to use the difference identity for the sine function in the numerator and the difference identity for the cosine function in the denominator. Now in the numerator, we have sine of theta times the cosine of 3 pi over 2 minus the cosine of theta times the sine of 3 pi over 2, all divided by cosine of theta times the cosine of 3 pi over 2 plus the sine of theta times the sine of 3 pi over 2. So now we want to use our knowledge of the unit circle to simplify these portions that we can. In the numerator, we get the sine of theta times 0 minus cosine of theta times negative 1, all divided by the cosine of theta times 0 plus the sine of theta times negative 1. So simplifying the numerator, our first term becomes 0. We're subtracting cosine of theta times negative 1. Those negatives cancel out, so we're left with cosine of theta. And then in the denominator, our first term becomes 0. We're taking sine of theta times negative 1, which is just going to become negative sine theta. Last step, using our quotient identity from earlier, cosine divided by sine is cotangent theta. We have that negative out in front, so we get the negative times the cotangent theta. So we started with tangent of theta minus 3 pi over 2, and we proved that it's equal to negative cotangent theta.